Okay. Hi, everyone. Welcome to Rule Evaluations from Nashorn to GraalVM. So my name is Oguzhan Onkal. This second letter might be new to you. If you cannot really spell it, you just replace it with empty string, and then it will sound a lot better or closer to the original one. So it's Oguzhan. So I'll just actually start with giving a background to you, and hopefully this will give some use case why I was actually involved in this topic, rule engine. And then we'll look at the Nashorn built-in JavaScript engine in Java 8, and then we'll look at to GraalVM, and after that I will try to summarize and give some maybe tips, hints, how we can actually migrate from Nashorn to GraalVM. So let's start with the background. So I work as a software engineer at UBS in a structured product solutions stream. So this stream has product factory crew, which contains applications to create financial products. And inside this crew, there is a domain called securitization, and this is actually where I work. Securitization is actually a public term, financial term, but you can Google it and you will find a broader definition. But in my context, let's say, this means actually distributing data to either internal services or external services. To actually do that, you need some kind of a mapping, because you have the domain called, let's say, securitization or anything else. Then you need to convert this to something to actually distribute to either internal or external service. Well, this could be, in my case, for example, this could be a stock exchange or some clearinghouse. To do that, first let's try to define what is actually a rule. So let's assume we have a context, and this context we would like to convert an input to some kind of an output, and executing some kind of rules. And the rule here is really given a business context. When a condition or this mapping is executed or evaluated, we would like to get a deterministic output. So let's say I have some kind of rules and I have a given input. Each time I execute the same rule with the same input, I should get some same output. So that's what we can define. But how we actually evaluate these rules? So there are different ways to do that, and one of them is extract, transform, load tools, or ETL tools shortly. This really means that you have some kind of source of data, you extract it from that source and convert or transform into something, and you then load this to some kind of a container. Another way to do this rule evaluation is using the Java POJOs. Well, we are Java developers. We can just write the code and do whatever we want with all those conditions. But this might be then difficult to actually scale the rules to some level, because you are embedding into your application, let's say. If you are using Spring Framework, you might use expression language. That's also useful. Another way is Apache Commons JXL, Java Expression Language. This is also a library which is useful, but actually outdated. So if you have something, let's say, lightweight, you could still try. Another framework is Drules. This is like a rule engine, and it's really allocated to this rule engine topic. And you can also write your custom tools. And the last one is actually JavaScript engine, which we will look at. And here I wouldn't say any of them is superior to other, because each of them has drawbacks and upsides and downsides. So it depends to your application, context, requirements, etc. Okay, so before we talk about the JavaScript engine, let's look at how it actually works. So you basically have a JavaScript code and you want to run this code on GVM. To do that, we have the parser usually, and this parser is actually converting that JavaScript code into some abstract syntax tree. And this syntax tree is the representation of that code in terms of the conditions, variables, etc. And then this abstract syntax tree is interpreted and converted to bytecode. So this is, in general, how it works. Of course, depending on the implementation, JavaScript engine implementation, the flow will almost look like this, but there could be optimizers as well. Okay, so let's also look at now how Java Oracle actually included this JavaScript engine in the stack. So it actually started with Java 6, and it came with Rhino. But this Rhino engine is actually removed with Java 8, and Nashorn was introduced. And Nashorn stayed till Java 11 and then Java 15. And between Java 11 and 15, Oracle also introduced something called GraalVM with version 19, and it was built on top of Java 8. And actually, it doesn't mean Oracle removed them from the stack, but actually these Rhino and Nashorn are still alive. So you can just go to GitHub and check their latest versions. So now let's look at Nashorn and how we can actually use it. So there are a couple of ways to access Nashorn engine. So the first one is under your favorite directory, which is Java home bin. So if you look at there are useful exes. And for example, JConsole, there is also a visualizer, as you know, to check the heap dump. But there is also something called JJS. This is the engine. So if you click to that, it will pop up some command line, and there you can execute actually a JavaScript code. And here we have a very simple example. We just define a variable, and we just print it. Of course, this is not very useful, and you would like to access it from the code base. And Java actually comes with JavaX library, which you see on the left side. And this library, here you see there's an abstract script engine. There's actually an interface called script engine, which you also see the class diagram there. So this abstract script engine is implementing that engine interface, which also Java provided a jar, which is Nashorn jar. It actually provides the implementation of that abstract script engine. There are also some useful actually classes like that. For example, script engine manager, which it will be useful for us in a bit. So now, and you also see the class definitions there and interface. So now let's try to do some basic examples, how we can actually use them. But before that, actually, this script engine has one core function called eval, which will be very useful for us. And it actually executes, and it actually gives us arguments to provide. For example, with string, you can get the JavaScript code embedded there as an argument, but also you can pass file reader. Well, any implementation of reader, but if you would like to pass a file, you can just send it there. There are also two, or actually four variations of it with context and bindings, but we'll come to that in a bit. So how we actually get to that? One thing we need to do is importing the script engine and script engine manager, which I just showed you in a bit previously. So what we need to do is adding one or initializing one script engine manager, and this script engine manager provides us three actually methods to access the engine. One of them is engine by name. The other one, engine by extension. There is also one with MIME types. The engine by name, so there are a couple of keywords that is given to us, and you can use any of them to actually access the engine. You can also access by the extension, which is in here only JS. Okay, so we have the script engine manager, we have the engine. There is also actually another way, since there is only one JavaScript engine built in Java 8. They also provided actually a factory, which is Nashorn script engine factory. So you can also create one of them and get the engine from that factory. And now we will actually try here the that very basic example that was in the command line, which you have this JavaScript code embedded as a string, and we pass it in. We pass it to this engine manager's script engine evaluation method, and of course it will print the for. So let's also look at a couple of more examples what we can actually do with this. So on the left side, I just put some simple examples, and on the right side, you see the code for it. So the same string that we had is now in a sample.js file, and since script engine provides us this file or reader argument, now we create a file reader and we pass it to the script engine. So yeah, it's very, very simple. And the next one is also similar to the above one, but this time we actually have a function. And you can actually also invoke functions using the script engine. And to do that, if you recall the class diagram, the script engine was also implementing the invocable interface. So that interface has a method called invoke function. And since the engine is implementing it, we just converted we just convert that engine to invocable, and invocable invoke function with the name of the function that we provide, it will give us the result. Also, there is another example here, but this time, if you notice, the method has actually arguments. And on the right side, we invoke the function, but we actually didn't give anything for the multiply. So any guess what would be the result of this println there? An exception. Anything else? Undefined. Okay. So it will actually return not a number. So it's not a. Oops. Okay. Sorry. So well. If it was Java itself, of course it would throw exception, but in here it's JavaScript, so it's getting undefined, right? But then the result is actually not a number for the multiplication. So JavaScript is a bit flex here. That's good question, but then we would have to try and catch this, right? So if there would be an exception, then we should be able to get that in Java as well, because these engines have interoperability features as well. So we would get the exception, but we actually need to. I mean, this snippet is just very simple, just focusing on evaluating the function, but in actual use cases, we need to actually try and catch these things. Should be, yes, yes. Let's say, well, this time we actually provide the arguments. Because this invoke function is also taking the arguments, actually an object array, and we provide this 2 and 5, and we get the result 10. And in the last example, we will look at something a little bit different. And actually, it uses the other variations of the eval method. Here you notice that we create something called bindings. So bindings are more like a global variable in this engine context. And you have the JavaScript code, but there might be cases that you don't have the constants or these global variables available in the JavaScript code, and it may exist in the Java part. So to actually pass that to JavaScript, you need to create these bindings. And bindings are also linked to the contexts. This context will pop up, or we will hear it a lot. So this context has links to global variables, which are called bindings. And we used here the script context engine scope. This is the default context. And we put the value of the pi there, and we pass the JavaScript file along with that binding, and we pass it to the evaluation method. And when we do that, we will get again the result. And of course, invoke function has this argument dr. Okay, so related to also the question, this is not all of the actually Nashorn, because you can actually also access Java part from JavaScript as well, using, for example, big decimal, java.mat big decimal. So you could actually write there in JavaScript and get the results using the Java code as well. But that part is a bit more complicated, and in real applications, my personal preference is not to do things like that, because then it may cause some issues when we actually need to migrate these Nashorn applications to GraalVM JS. But we will come to that in a bit. So now let's also take a look to GraalVM. So we have the Nashorn. It was in Java 8, but it was removed with Java 15. And now there is another option, actually, which is GraalVM, which we can use. This architecture diagram or schema is taken from the GraalVM page, which look nice. It describes all the features of actually GraalVM. So the definition of GraalVM is high performance polyglot virtual machine. So this is actually a virtual machine which can execute multiple languages, not only JavaScript. So at the very bottom, it has this virtual machine capabilities. On top of that, there's a compiler which improves the performance. And if you recall that JavaScript engine diagram, I was saying there could be some optimizers, etc. So that's GraalVM compiler is doing that. And on top of that, there's a language implementation framework. And this framework is called Truffle or Truffle API, which gives us the ability to execute multiple applications on Java. Well, in here we will only look at the JavaScript part, but it could actually even run C, C++. At the very right corner, you see this low-level virtual machine kind of languages. So we will just focus here only the GraalJS part, but if you would like to try, it also can run Node.js, Python, and others as well. So how we can get this GraalVM? So there are a couple of ways to do that. One is using the latest version, and you can just get the bundles which are built on top of Java 11 and 17. So you can just get those bundles and install. Another way, well, the GraalVM Community Edition is actually open source, so you can just get it from GitHub and compile it yourself. And also it's valid for the GraalVM JS. And the last part is more relevant to application developers, which you can actually add as a dependency to your project. And which we will also look at now. So this GraalVM JS related classes, all these things are under the package GraalVM Polyglot. I guess they just named it as Polyglot because the GraalVM can run multiple languages. So here we have again this context word and also the engine. You see the definitions from the API there. But to use it in your application or in your code base, you just need to add three actually dependencies. If you use, this is just from the Maven part, of course. One is the SDK, the core part. The second one is the Truffle API, which is the language implementation framework. But we want to run JavaScript, so we also need JS, GraalVM JS. And here I just actually added the 19 version because I was trying this with Java 8. But the latest version is actually 22.2. Okay, so now let's also do similar things with GraalVM, using GraalVM API. So one way to access this or run something on GraalVM JS is using the context. Here it provides us a little bit simpler, let's say, way to do that. So we just create a context, but this time the eval is also taking the language as a first argument. And in the first example, we just pass a JavaScript array. So we pass it to eval, we get the value, and then by using the array methods, we can access all the elements. Well, this one will fail because it's not actually 3, the third index, right? So the second one is again running a JavaScript code, but this time it's actually a function. It's just incrementing a value x to x plus 1. And we pass to GraalVM evaluator 41, and we get the result 42. The other example is a bit more looking more complex, but it's also easy. So this time we just pass actually a JavaScript object which has ID, text, and similar to that array, the first one, but this time in an object. And using again the result, we can access all these members. We can get those ID, text, array, etc. using the available functions there. So from this side, it's very easy to use compared to Nashorn. Now we will look at something a little bit more useful. This time we have something called input.json. This JSON has a one ID element, right? And then details of the product. Let's call it product JSON. And the product has a name and the location. And what we will try to do now is we'll try to write a rule and execute it using the GraalVM JS. So this time we just wrote a custom function which takes the data, and the JavaScript code then parses this JSON or input, which is JSON. Since JSON is very easy to access and manipulate in JavaScript, and now we can actually access inner elements very easily, like product details, location, for example. This is especially useful when you have, so you have more like a flat JSON here, but if you have really complex JSON structure, one of the libraries that we looked at, like Apache JXL, for example, that one will not easily access to these inner levels. So, for example, that can only access product.details, but not the location. To do that, you need to pass the sub part of the JSON again to the engine to actually access that level. So this also gives us a bit less work, let's say. Now, actually, another way to access GraalVM JS is using the old style coming from the Nashorn. So this syntax could be especially useful if you want to migrate from Nashorn to GraalVM JS, because here you leverage the script engine manager again. So this time, assuming that you added GraalVM JS to your project as a dependency, now you can access the engine using the GraalJS name. And it will return the script engine, and the implementation is GraalJS script engine. And the previous code, if you remember, is now almost applicable here. You just need to get the context from the GraalJS script engine. So if you were using the old style, you just need to replace a couple of things here to migrate. All right, so now let's look at some sample scenario. So what we so far passed to this JavaScript evaluator, you can they were very simple examples, but you can assume that they were actually some kind of a rule or basic versions of some rules, and these rules may be actually created by a business or business analyst. It was actually part of also the yesterday's one of the lectures. So business sometimes wants these capabilities, and to do that, you need to provide them a UI where they can actually evaluate or write their own rules. So here we have a very simple UI. Well, maybe let's first add the rules, and I'll explain the rest. So we will first add a rule, which is named as product location. We give a key called origin. I'll explain the key in a bit. And I think you also noticed the given when then. Business loves this kind of stuff. So the condition here is product.location, either PL or lowercase pl, and the result should be Poland, and the message is product based in Poland. So we define a rule like that. And we have another rule, product discount. This time we said, okay, the location is PL, but the product ID is 4. If that happens, we would like to get the discount code as a GDD 2022. And it has some message along with it. And now, so we have added these rules. So what does this mean? So if I pass input JSON to this, let's say, let's assume there is a engine behind this, and it is. So we have the rules defined. What does this mean? So if let's say we pass a JSON, if the product location is PL or lowercase pl, then we should get a result Poland with the key called origin. And for the first rule, if the product ID is 4 and the location is PL, this time we would like to get a result discount code equals to JDD 2022. And that's actually what we will try now. So this POC had also a evaluation, let's say, endpoint. So we pass a very simple JSON, which has ID as 1, location as PL. So we pass that to the engine, and the engine executes all those rules, which we had only 2. And it matches the second entry, which was the location of the product. So this time, we had the ID and location, but as a result, we got origin and value and some message along with it. And if we switch the ID to 4, this time we will get also the discount, because also the first rule is actually evaluated to true, which then we get the result. So actually, before going to these tips and pitfalls, we could also just take a look to the first slide here. So you may actually ask, how did the rule engine found the product, right? I mean, because we had rules like product ID, product location, but how did the rule engine actually understood this product keyword? So that was actually passed to the rule engine as a binding. And if you recall the previous code, so that binding is already in the context of the engine. And when we pass these rules, it's automatically evaluating the functions and getting the results. And but it is actually in the previous slides where you had this, we passed the JSON, if you recall, and this JSON is parsed into JSON object in terms of the JavaScript part, and then the rules are executed. So just to clarify that part. So coming to actually end, so to wrap up, let's assume we have a rule engine developed in Nashorn, and we would like to migrate it to GraalVM JS. Well, because, for example, your organization may want to move to Java 15 and forwards. So then the Nashorn will not be applicable. So you may need to do that. And to do that, you can actually just replace the bin directory with the GraalVM one. And if you recall, there was a jjs.exe under the bin. You also just need to change it to GS, and you may expect that to work. But if you don't want to just replace your JDK, and for some reason, then you can add this to your project as a dependency, like I showed previously. But if you do it as a dependency, then you need to actually you shouldn't have then performance expectations, because GraalVM GS, or its core, comes with that compiler, if you recall. And that compiler is actually doing all the performance improvements. But if you add as a dependency, you don't get that. But still, the rule engine part will work, and it will execute all those rules. And two more things. If you add GraalJS, I would suggest also you to check the actually implementation in the code, because some of the versions of GraalJS came along with Nashorn. So if you are using it, you just need to check if I'm actually using GraalJS or still is it Nashorn during that migration. And one last thing. So GraalVM also comes with these 3 methods, which could be useful. So we were creating the context using the context.create, but it has also context.builder. So you can pass these methods to that context builder, and what it does, it can allow your application to actually JavaScript code to access Java classes, public ones, of course, because by default, GraalVM actually doesn't allow that. So if you were using Nashorn, you were accessing the files, all those public classes in Java part, which I didn't recommend, then you may get exceptions, and to fix them, you may need to use these, let's say, methods. So actually, that will be it probably. So I'll just share. I'm just sharing here the documentation links, and there is also a Nashorn migration guide. It has actually also a link. Probably you could find there. There is also a migration guide from Rhino, so you could also get that. And also actually a link to Nashorn from the Oracle again. So if you would like to check those interoperability features of Nashorn, you could also check the examples there. And actually, that will be it. I hope this will be useful, and I would definitely recommend you to try GraalVM GS and GraalVM's other features, because it seems like it has a lot of capabilities, and it's worthwhile to actually try them. And as closing, please also try to visit our stand, a UBS stand, and you may get actually a free ticket to Byte My Code conference, which is happening soon. Thank you very much for listening, and I hope this will be useful for you. And also please share feedback, because GraalVM has lots of features, and if you would like to listen about those business analyst, business part of the things, that's actually another lecture, but we can also talk about just-in-time compilation, ahead of time compilation, those kind of things. So please share your feedback, and we could catch up again. Thanks very much. And